Yeah, okay, okay. Throw me some ideas that you have. It's okay, anything crazy. Okay, okay, yeah. So we're gonna be doing some calculations with the practical scenarios actually. So basically, by the physics, we are doing calculations or giving some numerical values to the day-to-day stuffs, right? Which means, as I asked from you, I asked like how long it took from your place maybe to the Bandara. It will be around, I guess, 1.5 hours, 2.5. Oh, so you're coming from maybe coming to the capital and thereafter to the Bandara, or not itself, straight away to the Bandara. It takes 2 hours. Oh, oh. So I used to work there quite a long time ago, like in that. I didn't know that there's a. Uh, it's not a hotel, I guess. It's a tea factory, like Heritage Tea Factory. You know about it? Okay, so I was working as a network engineer once, maybe a long time ago. So it's just taking an 1.5 hours, I guess. In that case, okay, fine. So I think you are coming from like two buses, one bus. Okay, okay, right. Okay, so anyhow, it takes around that 2.5 hours, right? And also, do you know how far from there to Bandara? No, no idea. So it's around like 42 kilometers from there. Not straight, but at least around 42 kilometers. So which means you have covered up this distance with this time. So here we are measuring up a certain distance. It is going to be a length measurement, right? So we are measuring the things. So if somebody asks maybe, okay, how far from your place to here, you can say, okay, it's quite long. Or else you can say it is just around 42 kilometers, which is we can convince the idea in a numerical way, or kind of like a quantitative way, right? Instead of just saying, okay, this far, we can say it in a numeric value. So we can have a good idea about here in the distance, right? And you can say how long it takes. Well, you can say it took quite long, or else you can say it's just 2.5 hours, which is much convincing than we say something in qualitative way, right? So by the physics we are doing is we gonna measure the things and give some numerical values and also doing some calculations as well. So for an example, if somebody asks how fast you came, you can describe something called the speed, which is the distance divided by time. And this equation we're gonna learn very soon in the next part. So in your case, the distance will be 42 kilometers. I can maybe convert it to meters too, by multiplying 1,000. And the time it takes going to be 2.5 hours. Maybe I could just do the math a little bit. What? How many minutes will be there here? Yeah, I could write here 2.5 means 2.5 hours, which means I can multiply by 60 to convert it to minutes, right? In this case, this is going to be minutes because there will be 60 minutes for an hour. Also, I can convert it to seconds again by multiplying it 60. Yes, so you can basically just multiply by 3600 to convert the hours to seconds, right? We can learn them very soon, right? The unit conversions and all. So you can put it there. So it's going to be 2.5 into 60 into 60 seconds. This is the distance that you have covered and this is the time you took. So you can cancel off maybe a few zeros here, and I'm going to do something like this. Let's say 2.5, I'm going to write as 5 over 2 for this calculation. It's 6 into 6. Well, I can cancel off this 42 as well. Yeah, it is 7. So going to be, okay, I can cancel off this with the 3. So it's going to be 70 over 5 into 3. Here the unit comes, here the meters, second comes up. So meters per second, right? Well, you can do the math here as well. Maybe I could divide by 5 first. So it is 1, 5, 2, 14. 14 divided by 3. And that's going to be around 3.66 meters per second. Right? It's a quite small speed, right? But yeah, you can say how, how fast you came. Yeah, you can say the bus came very fast, or maybe very slow, like a snail. Or you can say it is coming at this velocity or the speed, right? In that case, your answer will be much precise. And here we are doing some involving some equations and doing some math here, right? So throughout the physics course, uh, within these 2.5 years, because you're gonna have the A levels on 2027. So till that, we're gonna be learning these kinds of equations and sort of some theories that are involving with measuring the things or calculating things with the day-to-day scenarios. That's all. Okay, great. So I do have one tute with me right now, but I can give it to one of you, or else what I can do, you could just I'll add it to the group, so you can send me your address. I can post it to you, so you will be receiving it on Tuesday, hopefully, right? Okay. So because I thought maybe one is coming, so I just have one tube. Yeah, just one. But I can give that to you right now. I mean, when you are doing calculations, but I'll send you one of your own tube, right? For the time being, you can share this one. So the very first page, you can see the syllabus, right? There will be 11 units, and we have started the very first one, right? And that is about the measuring instruments or measurements. All right, so out of that, we have discussed about two measuring instruments last day, and that is called something vernier caliper. And the next one is the micrometer screw gauge. Uh, I think you have no idea about this one, right? Okay. All right, great. That's totally fine. Uh, so today, as for the theory, we need to learn about the next one, which is going to be something called spherometer and the traveling microscope. Okay, before that, I told you we need to measure the things. In that case, there will be some different measuring instruments. The very basic one going to be maybe a meter ruler, right, to measure up the distance. Oh, let me grab one. I saw a meter ruler upstairs. Well, I found one, but that is pretty broken. But it's okay, right? So you can use different measuring instruments to measure up different things. For the length measurement, you can use this kind of a ruler, very lengthy one, or else the ruler that you have, very short one, right? In measuring the length. Well, if somebody asks, what's the length of this table? You can have this ruler, keeping it like this, maybe you can measure it, right? That's a length measurement. Or else you can have the time measurements. So what are the gadgets that you can use to measure the time? Yeah, a measuring instrument that can measure the time. Okay, uh, let's be too simple. How about a watch? I can have a watch to measure the time, right? Or basically a stopwatch. You can see that tick things, right? You can start it and stop it and reset things, right? I can use a watch or stopwatch to measure the time. How about the mass? What are the instruments that we can use to measure the mass? මොනවද mass එක measure කරන්න අපි use කරන්නේ? Sorry? It's okay. Just a balance, I guess, right? It could be digital or the traditional balance that you have with the two pans, right? You can use those things to measure the mass, right? Likewise, in the beginning lesson, the very first lesson, we are only focused in the length measuring instruments, right? And from that length measuring instrument, uh, we have discussed up to here. First one was the meter ruler, very basic one, and the vernier caliper, then after the micrometer screw gauge, right? So maybe you can leave some space, or maybe you can how many pages that we have written already? Plenty, right? Yeah, yeah, I think we're plenty, right? Okay, so maybe you can buy a 80-page book, right? Uh, and you can go through the video sessions if you are if you are like convenient in watching them. If not, totally fine. We're gonna do that catch-up class, and you can come to that, and you can go through the very first lessons. Or else, uh, you can watch the videos, right? If it is working with you. So today we'll write the topic then. Okay. Do you have any doubts with the previous part? Okay. 23rd one. Okay. So I guess you guys need to be waiting for a long little time, right? We're gonna discuss the doubts that having with the previous part. Again, don't worry, right? Yeah, which question it was? 23rd, 6th. Okay, working on it. Twenty-third. Okay, 23rd. Sixth part. How to obtain the diameter of a sonometer while micrometer screw gauge? Is that right? Okay. Uh, yeah, you should explain. So it's not necessary to know about what's a sonometer. We can learn it not very soon, but in the third lesson, I guess. Yes, but it's basically a wire like this. Right? So you're gonna have that one to be stretched. Sonometer is basically a primitive version of a violin. I think you have seen a violin or maybe guitars, right? And they are having strings. Have anyone of you have done music for the O levels? How about you? No. No. Okay, but at least you have seen, right, the those instruments. So in that case, there are going to be some threads. We're going to play them to make a sound. So sonometer is having just one wire, a wire like this. So you should explain in that case, you should trap the wire in between the end wheel and the spindle. Right? Sounds very strange for you, but okay, fine, right? So you should trap that one in between the end wheel and the spindle, and using the ratchet, yeah, you can firmly grab the wire and not obtaining the diameter at one place. Even though the wire seems to be pretty much even, there could be some dents and some irregularities. So you need to at least measure the diameters at three different points and take the mean value. Okay. Diameter of thin wire instead of vernier caliper. Why is it so? Yeah, so the least count is smaller than the vernier caliper, and why are we supposed to have a least count that is lesser to actually reduce the error, right? So if you can remember percentage error is equal to what? The maximum error divided by the standard measurement, max error. I think you went through that one from the class that you missed. Right. Anyhow, you wrote the note, right? Okay. So maximum error of a measuring instrument is again going to be getting equal to the least count. So lesser the least count, lesser the percentage error. So you can measure the reading or to take the reading with a higher accuracy in that case, right? So that's what we need to write. Is that all? Doubts? Okay, great. Is that so? Okay. 16th one, it's first one I can say that it is 6 millimeters has been passed, right? 6 millimeters plus. Now the coinciding segment is going to be 35, 36, 37. Is that so? Okay. Next one is it's 0, 1, 2, 3, 3.5. And the segment will be 46. Next one again, 1, 2, 3, 3.5. Coinciding segment is 6. Next one, 1, 2, 3, 4. 4 millimeters plus coinciding segment is 9. Okay, great. Alright guys, so since we're gonna deal with the spherometer today, that is using some strange principle, and that is called the screw principle, right? It's basically how a screw works. Let me teach you that first, right? So Rashmi knows this one, and the other guy is missing today. I guess he's sick. We'll see. Right? So let me teach you how a screw works. I think I need to grab screws for you then. Alright, so the girl who's marking the cards is missing, so she has some screw nails, but I can show you two with this, right? You can have a pen if you have one, or else I can give these. And basically you can unscrew the head. Alright, like this. So you're gonna see, you can remove this one if you need, right? And you're gonna see some threads here, right? Do you see some threads there? Then you can hold it like this, and you can turn the pen. In that case, it screws in. Right? Which direction you need to turn the pen in order to screw that one in? කොයි පැත්තටද මේක turn කරන්න ඕනේ? Screw ඇතුළට යවන්න ඕන. මෙහෙම කර. Yeah, you should turn it like this way, right? You can hold the pen like this towards you, and you can turn it. The tip is pointing towards you. And turn it with the pen, not with the head, right? Head එකෙන් අල්ලගෙන pen එක rotate කරන්න. Which direction you need to turn? Yeah, to this side. So when you are turning something, we say it's not to the left or to the right. Yeah, we're gonna say if it is rotating towards the direction the hands of the clock go, we're gonna say it in the clockwise direction. And if you turn it the opposite way, we're gonna say it anti-clockwise or counterclockwise. So you can have the pen like this again, and you can turn it now. So you need to turn it to the clockwise direction to send that one in or screw in, right? Again, turn it from the pen, not from the head, right? You can hold this one firmly and turn it from this, right? මේකෙන් turn කරන්න. pen එකෙන් turn කරන්නේ මේක අල්ලගෙන. head එක අල්ලගෙන pen එකෙන් turn කරන්න. එතකොට හරි. Right? Okay, so that's how the screws working as well. So let's say this is the screw nail, that head here. And these are called the threads or the tines. Like this, okay. Like that, okay. So if you just turn the screw to this side, which means if you like see it from the front, it is turning to the clockwise direction, right? This screw will be moving forward, right? The same as your pen. It has been moved into the clip, right? Or the head. So I'm gonna fix it like this way somewhere. And if you turn it to the anti-clockwise direction, which means to the other side, this will go backwards, right? So if you like turn it by a complete cycle, do you know how far it will go forward? You're gonna turn the screw by a complete cycle. Maybe you can see it from your pen. First unscrew it a little bit, and seeing careful, you can turn one complete cycle. How far it will go? ඔයාලගේ pen එකෙන් බලන්න චුට්ටක් අරගෙන. First unscrew it like this, right? And keeping it like that, turn the pen by a complete cycle. Just one cycle at a time. Don't you see anything? That it is going in? ඇතුළට යනවා පේනව නේද? No. So how far? Well, it's going to be a distance between two consecutive threads, guys. If you turn this one by a complete cycle, this goes forward by the size of that thread. You can see the threads are being disappearing once you screw in, right? Yes. So which means if you turn it, this goes forward by the distance of the consecutive threads, right? And we're gonna give it a name. We are marking it as D, and the D is said to be the pitch of the screw, right? D is going to be the pitch of the screw. So in your case, the size of the threads are going to be not larger, right? It's going to be just around 1 millimeter. You can see it from the screw here, like the two consecutive segments there. Right? If you like place a ruler here, like this, you can measure up the length between two consecutive screws, and that's going to be around 1 millimeter. The pen, right, that you had. And we know if you just turn one cycle, how far this goes forward? By this distance, right, which is the pitch. If you turn it by a complete cycle, this goes forward, skipping the next thread, skipping to the next thread, which means it has moved a distance of d, which is the size of the two threads, and that is called the pitch. What if you turn it by a half cycle? It goes by d over 2. Complete cycle, it moves d. Half of the cycle, it going by half of the pitch. What if you just turn it by 1/4, which means you have divided the screw head here into 4 segments, and you have turned this one by half of it. No, sorry, 1/4 of it. It's going to be d over 4, right? And you can see how the things are going on. Let's say if you have divided the screw head into n segments, and if you turn it by a little n segment, that means 1 over n, how far the screw will go? D over n. And that is how we uh, find the least count. That means the smallest measurement that we can have from this micrometer screw gauge. You can see there's a screw term, which means it is dealing with a screw nail. And something gauge means we are measuring it. Micrometer means, actually, you know what a meter is, right? And I guess you know about the prefix. Micrometer means something like this, and that is given in the tube on the page, I guess, page 3. You can share 3 and share the tube for the time being, right? And there's a table given with the SI prefix there, and you can see there's a term called micro there in the table up. Yeah, do you see there's a prefix micrometer, micro, right, with that weird symbol here, like U with the extended arm like this, and that is to be having the 10 to the power minus 6 as the power. So we can measure up to 1 into 10 to the power minus 6 meters. That much of accuracy is there for this micrometer screw gauge, right? So this micrometer screw gauge, which we have learned in the previous week, and the spherometer here are using the same screw principle, which is this one, which means if you turn like a complete cycle of the screw head, this goes forward by a distance of d. Well, if you just divide it by two n segments, and if you turn it by one segment, it is going to be d over n. And guys, this is said to be the d over n is said to be something called the least count. That is the pitch divided by number of circular divisions. I could write in short that the least count to be LC, that's d over n. Least count means the smallest measurement that you can have from a measuring device. Do you have a ruler with you? Maybe I could find one for you. Or maybe you can have this one, right? So, what's the smallest measurement that you can have using the ruler that you have? The smallest measurement is broken there, but you can use here, or you can use the ruler that you have, right? Sorry. Okay, so 0. Okay, fine. Apart from 0, what's the shortest distance that you can measure? Yeah, Rashmi. What's the smallest measure that you can have from the ruler? 0.1 what? Meters? Centimeters? Ah, okay, okay. So you can see here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and here it's going to be the 1 centimeter. I have just zoomed your ruler here. And each of these calibration is not going to be this much of separated, right? I have just drawn it to be clear showing for you guys. In that case, you can see this is the 1 centimeter has been divided to how many segments? 10 segments, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There will be 10 segments. Right? I'm talking about the ruler that you have, right? So in between each and every centimeter here, 43 and 44, let's say, there will be 10 segments. So what's the smallest measurement that you can have then? Yeah, that's going to be this much of gap if you are measuring. And that is going to be 1 over 10 centimeters, because each centimeter has been divided to 10. So I can say the 1 centimeter to be in millimeters, which is going to be 10 millimeters, has been divided by 10. That is going to be 1 millimeter, right? You know that this little calibration here is going to be 1 millimeter, and this is going to be 2 millimeters, 3 millimeters, 4 millimeters, 5, 6, 7, 8, 9, 10, which corresponds to 1 centimeter. So if you're using the ruler here, the least count or the least measurement that you can have is going to be just 1 millimeter. Okay, got it? That's said to be the least count. That means the smallest measurement that you can have from a ruler. I mean, for any measuring device. But having a 1 millimeter reading is not going to be quite good when we are dealing with some critical values. Let's say, I have told this example earlier. Let's say we are manufacturing something that sent into the outer space, maybe a rocket or maybe a satellite or whatever, right? In that case, let's say we are sending it to the outer space. I think the usual example I'm going to take will be that ISS, which is something called the International Space Station. Do you know about it? No idea, right? Okay, great. That's totally fine. So there's this Earth, and this is the pearl, right, of the Indian Ocean, whatever. So there will be a lab, actually, a scientific lab that is just orbiting around the Earth, like going around the Earth, like the moon or like the other satellites you have heard, right? And that is called the ISS, International Space Station. Currently, there will be around 14 astronauts working with this lab. And they are on board in this lab, staying in the outer space, doing some researches, right? So this is like heavier, like several tons. This is not being sent exactly one time from the Earth. It has been fixed by sending few parts, right, in consecutive flights. එකම මේකගේ ඔක්කොම ටික send කරේ නෑ. Parts තමයි යාලා යවලා fit කරේ. Right? If it is on the Earth, we can fit the things, but if it is not getting fit, we can just maybe like shave it or maybe like do whatever the thing, right, to make it shape up to be fitting. But when it comes to the outer space, things gonna be crucial because we don't have the electricity and all, right? We have to be very much precise. So having 1 millimeter accuracy is not going to be good there, right? Not just that, let's say we are manufacturing some vehicle parts, all the cases we have to be much precise than just 1 millimeter. And that is why we are switching to these measuring instrument, guys. And we can have a lesser least count there. For an example, let's say the pitch of the screw that you had is just 1 millimeter. And let's say you have divided this one to 100 segments. So what's going to be the least count there? Will be divided by 100 then. In that case, you can have 0.01 millimeter as the least count, which means the smallest measurement that you can have. Like in ruler, it is 1 millimeter. In that case, if you are using this kind of a principle, we can go up to 0.01 millimeter, which is insanely accurate than taking 1 millimeter here. And yeah, guys, that is why we use this micrometer screw gauge, and it is using something called the screw principle, which basically having this relationship. If you divide it to the circular head is divided into n segments, the least count is going to be this much. Okay, so let's try the topic then. Without further ado, that's going to be the spherometer. Spherometer. Okay, so we write spherometer is also using spherometer is also using the screw principle. You know that this is tends to be hard, right? You should write principle to be not like this, right? Should be, otherwise it's going to be a very chaotic scenario, right? If the principal has seen this one, right? Screw principle. Okay. Screw principle, that PLE. Uh, Screw principle, and can be used to take some special measurements, and can be used to take some special measurements can be used to take some special measurements like the depth and radius of curvature. Depth and radius of curvature. Well, it's okay not to know for now about this radius of curvature, but I think you know about the depth, right? So, what's the depth measurement, guys? Yeah. Uh, let's take about this one right here, and there's a hole, right? And if you need to measure the depth, what you can do? You can maybe place the ruler inside like this and take the value as the depth, or else there's another device that you can use. What's that? Yes, there's something called vernier caliper. Don't worry about it too much. So vernier caliper can also be used to find the depth measurement, because there's something called depth rob that you can send that one in. You can go through that one from the video sessions, or maybe you can catch it up from that the next class or the catch up class. Okay, so you can use the ruler, or maybe if you need to be much precise, you can use something called the vernier caliper. in order to take the depth measurements. Apart from the vernier caliper and the meter ruler, we can use this spherometer to get the depth measurements. And also something interesting called the radius of curvature, which you may not able to find out from the other measuring devices. That's a special measurement that you can only have from the spherometer. Right? Okay, so we'll write, since it is using the screw principle, we'll write it once again, this one, right? For you, you don't need to write the entire thing. You can just write the least count is equal pitch divided by number of circular divisions. For you guys, uh, you can just sketch this one, the screw here. Lastly, we have considered about it, that's why I asked not to write for the Rashmi, right? But the you two guys, you can just copy this one, the screw here, and maybe you can use two colors to show that which direction it's gonna move. And D is said to be the pitch. Yeah, yeah, we can do it. Yes. So radius of curvature means something different. It's not this, the outer diameter, right? Something else. Hold your breath. Right. Okay, so this is to be number of turns. It's going to be the distance the screw moves forward. Okay, so let me know if you can't read my doctor letters, right? This is the distance the screw moves, number of turns, least count, pitch, number of circular divisions. Divide. Well, after you finish writing this one, okay, so for this you can write some example here where the D is equals to 1 millimeter and number of divisions is going to be 100. So after you finish drawing and writing all these stuffs, you can start drawing this kind of like a weird alien ship-like structure, right? And that's to be the spherometer. You can see one in the tube too on the page. Yeah, if you just go to the page, hold on. It's on the page 22 in the tube. If you need, you can refer that to page 22 in the tube. Or else let me project it to the screen too. This has to be straight, right? In my case, it is kind of not seems to be good. we are drawing this one, guys. In this case, it is kind of vivid here, right? This is the circular dial, and this is the oops, this one, and right. You can take your time and draw. Well, the vernier caliper and all, we have seen it in the I have brought one right to the class. Spherometer, I don't have one currently, but maybe I could find one for you later to show you, right? Okay. All right. So let's name the parts. This is the circular head or screw head. Screw head. Maybe I could use another color to draw that. This is called the circular dial. Or basically circular scale. And these right here, and there's a one here as well, right? So these are called legs. Pretty convincing, right? So it's kind of like three points that this can rest on a certain surface. These are legs. So this right here, it's called the middle screw or center screw. And this thing right here is the linear scale. Oh, yeah, sorry. Oops. Right. Seems to be spooky, right? All right. So you can clearly see the screw here. which is very much convincing that it is using this screw principle. But in the earlier one, which is something called the micrometer screw gauge, and there we haven't seen the screw. Rashmi can remember, uh, right? The screw is invisible there, but there was a screw which is hidden. In this case, we can see the screw very clearly. This is kind of like the same screw we have here, right? And that is also convincing us that the least count we can have from this one also, which is using the same screw principle, going to be which divided by number of divisions in the circular scale. Okay, so earlier one we had something called the thimble, right? The thimble is the one divided into several segments. But in here, guys, we can see there's a dial, there's a circular plate here that is being divided into several segments. Why do we need to have a large plate rather than having just a single screw? මේක එක screw එකක් නැතුව අපිට ලොකු head එකක් ඕනේ මොකටද? ලොකු circular dial එකක්. Yeah. Why do we need to have that? Hmm? Okay. What else? That's a specific purpose of we could have just the screw head, right? මේක විතරක් අපිට තිබ්බ නම් ඇති. මේක අපිට calibrate කරගන්න පුළුවන් 100 segments එකට. Why do we need to have a large circle, a large dial there? Okay, there's a specific reason for that. Well, think about this one, guys. Let's say we are dividing this circle right here to 100 divisions. Let's suppose like that. Or else we could divide this one to 100 segments. What's the difference it can make? No, actually, it's like this. Let's say you're gonna have a small circle like this one and being divided to 100 segments, right? So your calibrations will appear very much closer here. Even it could be hard to distinguish, right, if you divide this one to 100 segments. But larger the circle that you have, you're gonna have, yes, you're gonna have a large circumference in that case. So still we are dividing it into 100 segments like this, right? I'm not going to divide into 100 segments here, but you can see there, guys. If I just consider a smaller circle, the separation between two segments is going to be smaller, but the same segment can be taken from the larger circle. In that case, the distance between the two segments is going to be considerably higher. In that case, we can take the counts or the number of divisions there easier than you are having a small circle. That's why having a large dial could be able to distinguish the distance between two consecutive calibrations easily rather than having a very short or smaller circle. Got it? And that is why we have a large circle here like this. And that is getting tallied with something called the linear scale, which is pretty much the same as the ruler that you have, but not to be this much of length here. Very short ruler. You can see that part here, right? And that is having a screw nail here which is being connected, and that is being kind of coinciding or kind of touching with the circular divisions or circular dial here, right? Okay, let's see how we can take a measurement using this one. We'll write like this. Since the circular scale, after drawing this one, right, and naming all the parts, we write, since the circular scale has formed like a plate, like a plate. It can be divided to many segments. It can be divided to many segments. And the calibrations can be read easily. And the calibrations can be read. Read means read, past tense verb, right? Can be read easily. In a new point, right? For an example, when a sperometer with a screw of pitch is the P, right? Of pitch 1 millimeter and has 1000 segments in the circular dial. Come on, you can find out the least count, guys. Try to find the least count there. You can write least count. D over N in that case, right? What's the value you're going to have there? Yeah, it is going to be 0. Well, that's this. We have 1000 segments here. Can we just divide this one to thousands? Well, you can, guys. If you have a large circular dial, you can even divide it to 1000 segments, right? Without a hassle. In that case, it is going to be 0.01 millimeters. Even, guys, the 1 millimeter is very harsh to see. The ruler that you have, right? It is having a least gap of that 1 millimeter. When මේ measurement එක කියවන්න වෙනම ගේමක් දීලා, right? But here, see how far we can go in that case if you use a spherometer with having 1 millimeter of pitch, and this thing has been divided to 1000 segments, right? Well, yeah, even you can go to very higher values too, but the typical one, or the ones that you can find in the lab, it is just going to be divided to 100 segments or maybe 50. In this case, you can see, I'll just zoom it for you guys. So you can see here how many divisions there. Yeah, you can see here 10, 0 and 90. You could see it, right? It's 90 and here the 95 is there, which means it has been divided to 100 segments. If you start from 0, goes all the way 5, 10, 15 likewise, and he have 95 somewhere, which means it has been divided to 100 segments. That's how we can conclude. 100 will be like this, right? So it is 5, 10, 15 and so on, 95, 96, 97, 98, 99 and 100. 0 and 100 gonna be the same calibration. That's how we can identify. Okay, great. So we write afterward, but the typical spherometers have a scale of spherometer has a scale of least count. You can write in short LC 0.01 millimeter, having pitch 1 millimeter and 100 circular divisions. Having a pitch 1 millimeter and 100 circular divisions. Okay, now let's see how we can use this one to take a measurement. We write taking a measurement, a subtopic, taking a measurement using the spherometer. Well, I'm interested to ask which stream are you going to be doing the A levels, like maths or bio? Bio, you can do maths or bio? Bio. Okay, okay, great. Right. So we're gonna see how this thing right here to be using in taking a measurement, right? So we write step 1. There are a whole lot of steps involving in this one rather than the other case. So we write step 1. We write place the spherometer, on a flat glass surface, on a flat glass surface touching the three legs, touching the tips of the three legs, touching the tip of the three legs and the tip of the center screw. The tip of the center screw. You can write within brackets. This step is, we're gonna name this step as, don't write we're gonna name, right? We can write like this, within brackets, leveling the spherometer. Leveling the spherometer. In short, you can say that to be the leveling. So all you need to do here is take the spherometer, keep it on a flat glass surface. Let's say this is to be that flat glass surface, right? You can take it like this, and these are going to be the three legs, and there will be a center screw that is going in the middle, right? So you're gonna place all the four. I mean, in this case, it's not going to fit in, but okay. So we're gonna place it all the way on the glass plate here, or the glass slab, glass surface, right? Why do we are using glass? Smooth? Yes, that's the whole idea. So I gave you what's the purpose of doing this one. Why we need to like level the spherometer. Level means we need to first bring all the three legs here. There's a third leg that I'm not going to draw because it is behind this one, right? And the center screw to be on the same level, guys. This is the center screw, the center screw tip here, and this is going to be one leg. This is going to be the other leg. The third leg is behind this one, right? So we are trying our best to make the actually four tips, 1, 2, 3, and the four tips to be lining on the same level. That is why we say it's to be leveling the the spherometer. To level it, we need to have a perfect smooth surface. Otherwise, let's say it to be this kind of a surface, or maybe maybe any other wooden surface like this. Let's say about this one, right? You can see it's kind of shiny and kind of seem to be flat, but we are dealing with here very smooth readings like 0.01 millimeters. Even hard reading 1 millimeter is very hard. We can't of course see if there are any dents or maybe like irregularities with this surface, right, when it comes to these kinds of like woods and all. But when it comes to a glass, it's going to be very flat at all, right? You don't see any dents or maybe like irregularities mostly. In that case, we can use the glass to be confirming that okay, fine, all the 4 points are being on the same level, right? Let's say for a certain scenario, I'm going to use the same this one, right? And maybe the three legs to be like this. They are perfectly touching, but let's say the center screw here kind of stays up. I wish I could have another hand, maybe, right? Like this, maybe. Right? In that case, you can see, guys, here the legs are touching, but the center screw is kind of above, right? So what do you need to do in that case to bring the center screw down? මෙතින screw එක පහළට ගේන්න මොකද කරන්න? Are we gonna hammer it? No, right? Yes, you should hold it from the circular head, or maybe you can turn it from the circular dial also, but usually using the circular head or screw head, we can turn it to which direction? To the clockwise direction, so this goes down. If it could be the other way, let's say the three legs are up, but the screw has been sent more downwards like this. In that case, the three legs are not going to touch. What you should do? Yeah, you should turn it anti-clockwise and you can send it down like this. Right? All you need to do is take the four tips to be on the flat glass surface. That's the very first thing you can do. Well, you can sketch this one. Again, I'm saying there will be the third leg, which is kind of behind the center screw, so you won't be able to see that. And after you draw this one, you can write reading equals to M1. Alright? We write, there are two methods. After you write and draw all these things, there are two methods. Yeah, to the same step one. There are two methods of confirming the 4 points touching the glass surface. We can write first one. Right? So we need to be very much sure that the 3 points are touching, right? You can see here, if I just use these three, can you see? I can, if I use the three legs to be like this, and the center screw is sending down like this, right? We can't be sure that the center screw is exactly touching or maybe it's still above the surface, because again we are dealing with very small accuracy, So even though the point seems to be touching, there could be a little space between the glass surface here and the center screw, right? So do you know like any crazy ideas that you can confirm that these four points are exactly on the glass surface? Make a sound. Yeah, in the earlier one we had something called a ratchet which makes a sound, but in this case it is not. Just the screw. Can you think of any method? We need to be confirming that all the three, like the three legs to be fine because they are just resting on the glass surface. We should confirm that the center screw is also just touching the glass surface. Right? Yeah, I can take it like that because as if you know there's something called zero error answer, right? Well, there's one method that you can do like this, right? Let's say these are the three legs and you are now, let's say initially this one right here, the center screw is above the three legs. Well, while you are turning this one, it goes all the way down like this, and it is trying to eventually touch with the glass surface. But there will be a moment that it is exactly touching like this. Like this, alright, fine. What if you turn the screw even more? Yeah, if you turn the screw head even more, this center screw here gonna move a little bit down even further. And in that case, the three legs going to be lifted up a little, right? If you send this one somewhat extra, the middle screw right here, it's gonna lift up the legs because once you turn this one, turn it one clockwise, this goes downwards. And further you turn it, after the point it is got leveled, the center screw will be moving down and lifting up the three legs a little. So you are turning this one from the screw head. If the three legs got lifted up, what's gonna happen? The only point that is touching with the surface is going to be the tip of the screw. While touching with a single point like this, now it is going to be lifted up, right? The legs are now above the ground. What if you turn it further? It's going to turn the entire spherometer. First, it is just the screw head that is turning because now it is resting with the three legs. So the spherometer is not moving in that case, only the screw will be turning. But after it is being sent some extra move, the three legs will be lifting up. So the only point touching will be the point of the screw head here, or the tip of the screw here, which is going to turn the entire spherometer. So you can have just the point where the spherometer try to rotate, the entire spherometer try to rotate. In that case, we can confirm, okay, now the three legs and the center screw tip are on the same level. That is one method, right? So we write that one in words. We write first one, while turning the center screw, while turning the center screw by the screw head, clockwise, to make it leveled with the three legs, to make it leveled with the three legs, the entire spherometer, three legs, you can put a comma and write, right? The entire spherometer starts to spin starts to spin when the tip of the center screw moved a little extra from the level of the three legs. From the level of the three legs and lifting up the entire sperometer from the surface. Okay, so I know guys, I'm also not interested in writing lengthy notes. Throughout the course, I'm gonna give you some short and sweet notes with some points, unlike the bio, right? Or maybe chemistry. Uh, but sometimes there might be scenarios we need to write these kinds of little paragraphs to explain the process, right? Okay, that's the first method of leveling the screw, leveling the three legs and the center screw tip. But this is not going to be very much accurate because we can't be pretty sure that the legs are being lifted up and start to spin the entire thing. Instead, we're going to use some precise method, and that is called observing the image. We write the second one, 2. We write observing the partial reflection. Observing the partial reflection. Reflections. Now the step 2, right? Second of how we can level it. Okay, great. So what does it mean by partial reflections, guys? Kind of half reflection, right? Okay, fine. I think you have seen, right? Or maybe you have done this one. Maybe in the schools, or maybe like maybe outdoors, maybe in the Gregory Lake, right? There used to be having a whole lot of parking lots, and there are a whole lot of vehicles, especially in the seasons, right? And let's say you went there, maybe for a boat ride, and you feel like your hair is kind of messy. So what are you gonna do? There will be a vehicle close by, and from the reflection, you're gonna just turn your head, or maybe like you can have your own phone, but without opening the selfie camera, you can use this one, and maybe you can just shape you up. Right? In that case, these are not intended to like work as mirrors. So mirrors are of course being specially made to give it a reflection, and that kind of a reflection we say is to be not partial reflection, it's going to be a full reflection. But when it comes to glasses, guys, like this one, these are being used to like penetrate the light through, like the glasses here. But you can see there, observing through the glass, there will be some images, right? Which is tend to be the partial reflection. So every glass surface, every smooth surface does this partial reflection. Full reflection happens when it comes to a mirror, but the shutters of the vehicles, they are like just glasses, but yet you can see an image of yourself, and that is from the partial reflection. Here also, do you have phone with you right now? Okay, so again, can you grab one? It's mom's. Okay, so maybe you can bring one, right? You can go out and do you have phone with your mom? At least? Nope. You have one. Okay. So may I ask them to give? Okay. Miss, may phone දෙකක් තියෙනවා චුට්ටක් දෙන්න. තව එකක් තියෙනවද දුව එකක් මොකක්ද? Right, thank you. මම ගෙනත් දෙන්න. Okay. You can have I don't know. This one belongs to you, I guess. Clicked. Okay, fine. Now you can keep it on the desk and have a tip of a pen, right? And I think you can see some reflection through this your screen, right? A reflection, not turning it on. And I need all of you guys to bring this tip of the pen closer to the display. Don't punch it, right? No, I mean just closer. Do you see a reflection of the tip there? Reflection of pen. You can maybe take it, lift it up. You can see, right? Do you see? Okay. So if it is not been touching, you can see the reflection here, the reflection from the screen, and the tip are kind of not coinciding there. ඔයාලා පෙනේ මේ ටිප් එක තියෙන ටිකක් උඩ. Like this. And the image of the tip is going to be somewhat like this. Isn't it so? Not to be touching. But now it's the time for you to just touch the tip on the display. Again, don't punch it, right? Once you touch the tip on the display, you will see what? What do you see? You will see in that case the tip here and also the shadow or the reflection are going to be coinciding. Isn't it so? You can maybe hold your phone like this. In that case, you can see that one clearly. Take it all the way down and touch it. Without being touched, you will see there's a gap between the shadow and the tip of the pen. But once you touch it on the surface, the shadow or the reflection and the tip seems to be coinciding in that case. පේනව නේද එහෙම? පොඩ උස්සලා බලන්න එතකොට reflection එක ටිකක් දුර තියෙයි. ගෙන ළඟට ගෙනහම පේන්නේ දෙන්න coincide වෙනවා. See that? Right? Okay. That's the method that we're going to use. Here you will see that the shadow of the legs as well, because we're going to have 3 legs there. Since the legs are being on the surface, that is totally fine. The leg and its image are going to be coinciding. But the center screw will not be coinciding. But once it is being touching on the surface, we can say for sure, right? It's going to be touching, the center screw tip is going to be touching with the surface. And that is how we can use this method to confirm, okay, all the 3 are, or the 4 are in the same plane. Yeah, that also would work, right? Like the glasses that you can see, right? It's also showing the same thing. And you can place it on a surface and observe. Right? එකම විදිහට පේනවා, but not going to be very much clear like these kinds of images because there's a reflective surface below, or most of the time it's going to be black in this case. But the other ones, it's going to be a very, if it is a clear glass, yet the same thing works, but the image can't be hard to distinguish. But it's okay, you can use the same method, right? Okay, so we'll use, we can just draw this one first, right? මේ දෙක sketch කරගමු side by side. This side, the other one. Oh, you have found an easy method to draw the legs, right? That's good. Be creative. Oh yeah, yeah. I believe you guys. This is has to be like not like this. The image has to be like this. Sorry guys. It's okay. Fine. While you're drawing, since these days, I hope you guys are kind of relaxing because you don't have much to work, right? So maybe I could recommend some movies to watch, uh, which going to be helpful for us throughout the course. So is there a way to download the movies and watch? Or maybe like, do you have Netflix account? Or maybe like, let's say your brothers or maybe like sisters are not especially but sisters or in-law with the brothers, right? Working is downloading the movie. So let me suggest some movies to watch. Have you watched that something called like Chernobyl? You have? No. So these are called HBO mini-series. There will be like 5 series. Each of will be half hours. No, sorry, 1 hour. I'll share you the links, right? You can watch it. And there are many. Since you have the time, you can watch it now because later on there will be a whole lot of workload coming up. So you won't be able to watch anything at all, at least the cartoon. Okay, I hope you have finished it drawing. Make sure you're drawing the images to be in dotted lines. And let's write like this under this one. Turn the screw head, turn the screw head, turn the screw head clockwise, observing the partial reflections. Observing the partial reflections of the center screw tip and its image. Of the center screw tip and its image through the glass surface. Center screw tip and its image through the glass surface. Once the tip and its image, once the tip and its image coinciding, confirms. Once the tip and its image, once the tip and its image coinciding, confirms that the center screw tip is just touching the glass surface. Confirms that the center screw tip is just touching the glass surface. Leveling with the 3 legs. Leveling with the 3 legs. Alright guys, those are the 2 methods that we can use to just level this one on the surface. Why do we need to level it? Well, we need to bring all the 4 tips to the same level, right? And let's see why again. What we are going to do here, to take a measurement, right? All right. So we'll see how we can measure up the thickness of a certain uh, thickness or the depth of a certain maybe an object, right? So let's say you need to measure up the thickness of this phone right here, right? All you're gonna do is place it the phone like this. We know already we have leveled the three legs and also the center screw like this. Okay, fine. Now we have already leveled this one on this surface, right? Let's say it is been leveled. Now if you need to take the thickness of the phone, all you need to do here is we need to make the phone to be, we are keeping the phone also on the same glass surface, and now we need to take up the center screw so that the center screw tip is touching the upper surface of the phone while the three legs are touching the other surface, the glass. I will show it to you from a diagram like this. Now the earlier case it was like this. Now we have already leveled it. Now if you need to see the thickness of the phone, let's say this is the phone right here. These are the legs. So what we should do in order to like fit the phone in, we should lift up the center screw tip, right? How we can lift that one up? By like just tearing it apart? No, right? We can just turn it anti-clockwise. So we know that the screw goes upwards, and by turning it anti-clockwise, we should firmly try to make the tip to be now touching with the upper surface of whatever the object, right? To do that one, we need to lift up the center screw tip here. To do that one, we need to turn the screw head to the anti-clockwise direction. Now let's say the thickness here is to be the H or the D. Let's say it to be the H, and let's say the reading here is M2. I'm going to show you how we can take a reading, but let's say the reading to be M2. Earlier case, when the four tips are coinciding or are in the same level, the reading was M1. How we can find out the height of this thing? Yeah. So we need to use these both things, right, to take the reading. This is to be the reading 1, and maybe I can turn it all the way, and the next reading going to be the reading 2, the M2. You can change the, okay, maybe let's say the reading here, once all these are coinciding, will be 0.02 millimeters. Again, I will teach you how we can take the reading, but let's say it's going to be like this. The reading here is going to be 2.56 millimeters. What could be the height then? What could be the size of the object? Here we have taken two readings, guys. This is going to be the upper reading. This is going to be the reading where the four tips are in coinciding, right? So you can take the difference, right? This you can have like 2.56 millimeters minus 0.02 millimeters, and that is going to be 2.54 millimeters. So you take the first reading here once they are leveled, then you're going to take the reading once the tip of the screw is touching on the surface of the object, then take the difference. That's all you need to do. Okay, so we'll write step 2. Step 2. Place the object on the glass surface. Place the object on the same glass surface. Oh, sorry. We write like that. Place the object on the same glass surface which the thickness need to be found out. Which the thickness need to be measured or need to be found out. Which the thickness need to be measured or need to be found out. Right? And place the spherometer above it. Place the spherometer above it so that the three legs are on the glass. Three legs are on the glass and the tip of the center screw touching the upper surface of the object. Touching the upper surface of the object by turning it anticlockwise. By turning it anticlockwise. Alright guys, now you can sketch this one and write the reading to be M2. Just that one, right? This diagram and the reading. You can show that it is being turned anticlockwise and the screw has moved up. Yes. Yeah, legs will be always level because these are being connected to the same spherometer. They are not moving. Think about this like an alien ship that is just resting with three legs, right? Like this. So the legs will not move, so they will be always level. We should somehow level the center screw. You can mark their edge, but we'll write this one later. Just mark only the edge. Turn it anti-clockwise, moved up, reading M2. I know this part sucks because we are not doing some calculations. But what to do, right? We need to know about the instrument. Okay, great. Now we'll write afterward. The difference between the two readings. The difference between the two readings. The difference between the two readings gives the measurement. Gives the measurement. Okay, now you can write H equals M2 minus M1. And with that, we're gonna have that 5-minute break, and you can go around, have some fresh air, and come back very soon. We're gonna be continuing how we can take a reading. Now we saw that we need to take the readings, right? And we should take the difference. We'll see some practical examples, and also, interestingly, we're gonna find out, or we're gonna learn how we can use this one to find out the Radius of curvature. Okay. Finally break. Okay, go around and come. Now it's 11:10. Okay, come by 11:50. All right, great. Now, since we need to take a reading, let's see how we can do that one, right? Okay. Mm, For this one, I think we can use one of the example given in the tute. So you can just navigate to the page 21. Page 21. And Rashmir, I think you have two tutes, right, that I have given you. Okay, okay, right. So do you have one with you right now? No, right? Okay, that's okay. So have you written that one in the new tute that I have given you? Did you write anything there? Okay, okay. So are you guys gonna meet other than this class on the next week? No, right? Okay. So if so, maybe I can just ask you to give one. Oh yeah, you can. I'll just post it to you. Okay, fine. Yeah, 24th question on the page 21. Page 21, question 24. Shall we try it now? Yeah. Did you try? This is not in taking a reading, but it's asking something. Yeah. A Spherometer with a least count of 0.001 millimeters need to be made by using a screw of pitch 0.25 millimeters. The separation between two considered calibrations reduced below 1 millimeter is not comfortable for eye in taking a reading. What is the radius of the dial it should be constructed for a spherometer to get the readings considerably? First, we need to find out how many divisions are there, the circular scale divisions. First, find that one. No, it's not 1000. First, find out number of circular scale divisions, which means we know the least count is equals to pitch divided by number of divisions. So you should find n first. Just find the n. Yeah, what's the n you got? Still working on it. 0.001 millimeters. That's the least count we should have. Here the pitch is given to be 0.25 millimeters. Number of division is the thing we should find out first. So you could do a cross multiplication. I can just take this to n to the other side and take this to the other side. So it's going to be n equals 0.25 divided by 0.001. Best thing you can do is just multiply up and below by 1000. So below we're gonna have 1 and above we're gonna have 250. So basically n is going to be 250 divisions, right? And that is not the answer here, guys. We should find out something else. We're supposed to find the radius of the dial. 1 hour? Not really. So it's going to be like this. Good try. So we need to have a dial that is having how many segments? 250 divisions has to be there, right? Because we're gonna divide the entire circular division. We're gonna divide the entire circle into 250 divisions. And it is saying, guys, the distance between two consecutive divisions has to be at least of 1 millimeter. Now you can see here this is being divided now. The distance between two segments here has to be at least 1 millimeter, otherwise it is hard to distinguish by our eyes. You have seen that one already from the ruler, right? This is the 1 millimeter calibration, the two segments. If you divide this one even further, can you be able to read that one very easily? No, right? It's going to be very hard. I just need to see that one like that, right? Still, it will be hard. So it is saying that, okay, the two consecutive calibrations has to be at least with the separation of 1 millimeters. How many divisions are there altogether? 250 divisions. So can you guys have a value for the entire circumference of the circle? Each segment is 1 millimeter, supposed to be 1 millimeter, and there should be 250 divisions, which means if it is 0, the other side we should have 249, and this is going to be 250, right? Out of that we have 250 divisions. What can I say about the circumference? Has to be what? 250 millimeters, no? You can just cut it from here and you can stretch it out like a linear path, right? In that case, how far it should extend? Should be 0 here, 250 here, 1, 2, 3, 4, like that. Each of these segment has to be 1 millimeter. So if you then curve it and forms a circle, that's how we can have this to be divided into 250 divisions. Okay, it's like this. So make a segment 1 millimeter. ඒ වගේ segments කොච්චරක් තියෙනවද? 250 තියෙන්න ඕනේ. එහෙනම් මේ ඔක්කොම වටේට ගිහිල්ලාම මෙයාගේ length එක කොච්චරක් වෙනවද? 250 millimeters වෙනවනේ. That gives the circumference. But we shouldn't find the circumference. Instead, we need to find the radius. Do you know an equation involving the circumference and the radius? Yes, good. Very good. So it is going to be 2 pi r. So this is has to be 250 millimeters. And this is going to be 2 into, we can take it to into 207 pi. We're supposed to find the r. That's how you do it. Got it? How about you? Got it? Great. We can maybe copy it down. And again, guys, this is not how we can take a reading, right? This is like a creative question that we have found out was the radius of the circular dial here has to be. Now, we are finished with that. Now, we can have like tilt. This is question 1. Dude, and question 20, 24. Starting from here, right? Least count this one, and this. Therefore, maybe circumference. Putting out laziness, you can find out the value of the r here, subjecting it. 31 point. Okay. 7. Alright, that's fine. 39.71. Cashews, pebbles. Yeah, we have taken that one in circumference in millimeters. The radius also you should find in millimeters, right? You can rush me? Do you get this one? 39? No. 76. Okay. Yeah. Okay, 76 or 77. Okay, so this is the radius you should get, right? Not getting that? All right, that's fine. So here, what I have done here is just dividing both sides by 2. 125, so 2, 875 divided by 22, whatever, right? Okay, you should get somewhere value like this. Okay, great. Uh, Now let's see the question 27. On the same page, question 27. For the time, just write this one, right? And you can do the math if you not get that. 27. Okay, so it's a scenario like this one, guys. You have given the two readings. Instead, you have given another reading, but to be the how the scales are. Here we have the 0, and here we have the 1, and the dial is somewhat like this, and it is saying that it is with the 346 calibration that is coinciding, right? The other one here states here the 0, 1, 2, okay, sorry, 2, this is 1, this is 2, this is 3, and above the 3 we have something called 886. So we should somehow take the reading M1 and M2. Well, it's pretty much same as the previous one, which is the micrometer screw gauge. You can take a reading like this. Reading equals reading from the reading of the linear scale plus least count into coinciding circular division. Well, this is how we can take a reading. Same as the previous one, guys. Let me show you how it happens. Well, we have that linear scale here, which is this one right here, and we have the 0. Let's say in a perfect spherometer, the 0 and 0 here should be coinciding. So this is going to be the 0 of the linear scale, and this is going to be the 0 of the circular scale. You can see there's a 0 in this circular scale too. This is the 0, right? And this is the linear scale 0 here. I can zoom it to you and show it maybe. Here you can see the circular scale 0 here and the linear scale 0 here, right? If it is a perfect one, which means where we don't have any errors at all, when all the three, the legs and the center screw tip are being leveled, right? Which means we know how to level it, right? If they are leveled, the 0 and 0 should be tallying like this, right? But in case here it is not, right? You can see here 0 is here and the other 0 is kind of here. It should be somewhere here, right? I think you quite got that now, right? 0 මේ linear scale එකේ තියෙන 0 එකයි circular scale එකේ තියෙන 0 එකයි ගානට මෙහෙම turn වෙලා මෙහෙම match වෙලා තියෙනවා, coincide වෙලා තියෙනවා. That means they have to be in the same line like this, right? And let's say we need to fit something in like this. what we should do? We should turn it anti-clockwise. So when we turn it anti-clockwise, you will see how the calibrations are. You can see here 0, 10, 20 likewise going on. So it is like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 likewise going on. And on the other side we can have, if it is being divided to 100, let's say, we can have here 0 and 1, 2, 3, 4. This is going to be 95. All good with that? In this example, it is not, you can see here it's 90, right? So 90, 95, then, okay. Right. So, what I should do again? I should turn this one to the anti-clockwise. So while you are turning this one anti-clockwise, you will see with this 0, first 5, 10, 15, 20, likewise it is passing, right? Let's say I have turned it by a complete cycle. How many calibrations will pass? It is divided to 100, so 100 calibrations will be passing. And we know again, if you just turn it anti-clockwise, the entire screw will go up by a distance of d, which is the what is known as the pitch, or maybe the distance between two consecutive threads. Got it? Great. If I turn it by two segments, two complete cycles, 2 times d. 3 cycles, 3 times d. Right? So this scale right here, which is the linear scale, will be calibrated in as the size of the pitch, which means it is going to be like this: 0, 1, 2, 3, 4, 5, likewise going on. You can see here similar thing: 0, 1, 2, 3, 4, 5, right? So you can see here these are being calibrated then again in millimeters. This is 1 millimeter, 2, 3, 4, 5, and so on. So if I just turn the dial by a complete cycle, the entire dial will be lifted up to this calibration. Because we know if you turn it, it goes down clockwise. If you turn it anti-clockwise, it goes up by the distance of the pitch, which means the distance of two consecutive threads. If you turn it by an anti-clockwise by a complete cycle, එක cycle එකක් සම්පූර්ණම turn කරොත් මෙයා upwards යනවා pitch එකේ distance එකට. එතකොට මේ circular plate එකත් කොච්චරක් ඉස්සෙනවද? මෙන්න මෙතෙන්ට ඉස්සෙයි. මේ segment එකට. If you turn it again by a complete cycle, this will lift it up to the next segment. So in here, how far it is being turned in this one? Complete cycles kiyak turn kala? Yeah, for sure we can say 2. 3 එකත් pass වුණා නම් අපිට කියන්න පුළුවන් 3 cycles completely pass වෙලා කියලා. But now we can say only it has been passed 1 cycle, which means it has moved by 1 millimeter. Again, another cycle, which means 2 millimeters, and not by a complete cycle afterward. Got it? So to fit this part in, for sure, we should turn this one by 2 millimeter to like 2 cycles. Each of the cycles it goes by the size of the pitch. In here it is going to be 1 millimeter. Right? So that is why, guys, first we need to take the reading of the linear scale. Linear scale එක reading එක මුලින්ම ගන්නවා for sure. මෙතනනේ ගන්න පුළුවන් 0 1 2 3 තියෙනවා නම් 3 වලට middle ගාන කියා ගන්න බෑ අපිට. But we can say for sure the 2 has been passed. So we can take it that reading 2 millimeters plus. Right? Now tell me, what's the least count of this one? Yeah, we can find that one here. Observing the pitch. Pitch here is going to be 1 millimeter. Sometimes for the question the pitch will be given, the d equals some value will be given. If it is not given, yet you can find out observing this linear scale. I told you the linear scale will be calibrated size of the pitch. Now you can see here the linear scale calibrated in millimeters. So the size of the pitch going to be then 1 millimeter. How many divisions are there? Yeah, in this case you're gonna have 100 divisions. But what can you say about this? Yeah, we're gonna have 1000 because we can see 886 not being divided to 100, right? So we're gonna have it to be 1000 segments. If you turn this one by 1000 segments, this goes by the distance of pitch. But from that 1000, how far this has been turned? Only 886. If it is complete cycle, it is going to be 1000. But now it is not a complete cycle. That is why it is not being coinciding with the 3 here. 2 has been passed for sure, but now it is 886. That is how we can take a reading here. So least count you can find out again by pitch divided by number of divisions in a circular scale. You can find out the number of divisions here in this example. My bad, has to be n equals 1000, not 100, right? In this example, just correct it. 100. It has to be 1000, right? But somehow in this question it is given the n and the d, but there are situations the n and d is not given, yet you can find out from observing this scale. Got it? Okay. And you can have a good handheld experience when we discuss about the previous one, which is the micrometer screw gauge. We have done the same thing there. Instead, the scales are different, but use the same equation, right? Don't worry about too much, you will get the practice. I think you can write here tute 27, and it's better you could just draw these two. Just sketch it. You don't need to draw these, right? මේ දෙක අඳින්න ඕනේ නැහැ. Just draw the scale. මුලින්ම equation එක ලියන්න මේක. ඊට පස්සේ scale එක ඇඳ ගන්න. You can take the reading thereafter. This is for this one. You should find out this too. I'm repeating again, you don't need to draw these two diagrams, but you're supposed to draw this scale and this scale and take the readings separately. You should find out the M1, guys. M2 I have found it already. Not being simplified, but the way that we can find out the M2. afterward take the reading and subtract from highest, least from the highest. Okay, so I'm going to take the M12. How we can take this reading? 0 millimeters has been passed, but not 1. Uh, yeah, so I told you that we have found out the M2 here. M2 එක තමයි අපි හොයාගත්තේ using this equation, and now here in this case 2 millimeter has been passed. 2 millimeters plus least count 1 millimeter has divided to 1000 segments, and it's 886 coinciding. So it is 2 millimeters plus 0.001 millimeters into 886, right? And that is to be 2 millimeters and 2.886 millimeters. This is the M2, which is this reading, right? M1 will be here from this. We can say that 0 has been passed, guys, but the 1 hasn't passed, so it is 0 millimeters. Plus, what we should do? Least count again, 1 millimeter divided by 1000 segments. Now the 346 one is coinciding there. So M1 is going to be 0.346 millimeters. This is the second drawing that you need to do it in case, right? Yeah, you can subtract the, yeah, so in here, guys, this is the highest value, I mean the larger value that we have obtained by turning it anti-clockwise. So once you turn it anti-clockwise, it goes upwards, showing a higher value. Now we have turned it by this much. From where? Not starting from 0 0 coinciding. පටන් ගන්නකොටම 0 0 coincide වෙලා තිබ්බනම් like this, reading එක වෙන්නේ කොච්චරද? This value. But once you leveled it, මෙන්න මේක level කරාම ආවේ මෙන්න මේ value එකට. Not 0.0 millimeter. What we should do? මෙතන ඉඳන්නේ අපි මෙතෙන්ට ගිහිල්ලා තියෙන්නේ. First we leveled it and the reading was this one. Then we have gone from here to there, right? M2. So how we can find out the size of this thing? H is going to be equal to, now we add M2 should subtract M1 from that, and that is going to be 2.886 millimeters minus 0.346 millimeters, and this is going to be 0, this is going to be 4 and 5, 2.5. Yeah, so usually when we get the 0 at the very end, guys, you are not usually writing it, right? අන්තිමට මොකක් හරි subtract කරලා 0 අපි ලියන්නේ නැහැ නේද? මෙහෙම නිකන් ලියනවනේ ඔහොම. But here you can't. You should definitely put the 0 too, even though the final decimal has to be 0. Why? Because we can say that here our readings were taken to 3 decimal places, and we have an accuracy of up to 3 decimal places. So even though you have the 0 at the very end, you're supposed to write it, right? And that's how we can take the reading. Alright guys, so with that being said, it's going to be your luckiest week because you're gonna have only few MCQs and a few essay questions to try as homeworks, right? So I'm recommending you two guys to go through the previous part once I shared you the videos before the next Monday, and it's going to be helpful for us to discuss about the next measuring instrument, which is going to be the traveling microscope, right? I'll share the very first video of this measuring instrument series, and that is teaching you about how the vernier caliper works. And vernier principle is not going to be like this, it's going to be a very different one. You're supposed to know it before we move into the next one. Also, in this one also, in order to take a measurement, we need to be familiar with the micrometer screw gauge, which is using the same principle here, but the instrument is kind of different, but using the same method. Right? If you are okay with that one, next day is going to be very much easier for us guys, because we are going to consider about first. There was a strange measurement that we can have only from this one, as I told you, and that is going to be what? The radius of curvature. Still we don't know how to take that measurement. Before that, we need to be familiar with how we can take a measurement using this one, like the linear measurements, these things. මේ ටික ගන්න අපි හොඳට හුරු වෙලා තියෙන්න ඕනි. Radius of curvature එක හොයන්න. ඒක නිසා we'll try our best to get these measurements, right? And familiar with the other measuring instruments. So next day, hopefully, we can finish up this part, and we can move into the next part that is called something vectors, right? Okay, so let me give you the homework that you can do. Currently, you can write it maybe on the book, right? Are you guys gonna meet after this one? Are you close by? No? Okay. So maybe one could take out the tube, but I'm gonna send you both, right? The tubes. Alright? Decide who can bring that, right? කවුද ගෙනියන්නේ කියලා පොඩ්ඩක් හිතලා බලන්න. එහෙම අවුලක් නැහැ. මම දෙන්නටම tubes දෙකක් දෙනවා. Right, okay. Let's see. The questions that you can try today will be limited. Okay. So you can try the 25th question. 25th one. Then the 26th one. 27th we tried, so you don't need to do that. 28th one. 28th. Right. Then 32. 32. Alright guys, that's all for the essays. We'll go for the MCQs. There will be MCQs too, starting on the page 27. From that one, you can try you can try the last MCQ. There are 67. And that's all guys, right? That's all for today. But last week it was like having too many homeworks, right? Okay, so yeah, we can wind up now. Now it's around almost about 12, but we have 3 minutes left. So next day we're gonna be learning about how we can use this spooky gadget to find out the radius of curvature, and we're gonna learn what exactly the radius of curvature is, right? And we can learn about the very last instrument as well, and that is called the traveling microscope. With that, we can finish up the measuring instrument part, and that is going to be the very first part of these measurements. And there will be a next part that is called the vectors, and hopefully we can finish up the first lesson too. Not by the next week, but maybe within 2 weeks. And thereafter, we're gonna be moving to the very giant of the syllabus, and that is called the mechanics. Right? I think you have learned about the Newton laws, the guy who has fallen an apple, so he said, right? And we're gonna learn about the Newton, how he explained the laws of motion and how we can apply that. The very famous equation, something called F equals ma, right? And sort of stuffs, and so on. Okay, so finally, let me introduce myself a little bit. Uh, so I'm Supun Jalat, but usually I'm using the Isanga Supun Jalat. So I did my A levels in 2015 at Bandaru Central College in English medium, O levels and A levels. I did both in English mediums, and thereafter I entered the university by the very first try, and that's University of Colombo, right? And I studied as the BSc, Bachelor of Science, Electronics and IT. It's there, blah blah blah, right? So Electronics and IT Hons. That means I got an honors degree there, and thereafter I'm working in a I did my intern in the Ceylon Electricity Board, and thereafter I'm currently working as an electronic automation engineer in a Singapore company. Uh, they are manufacturing some robotics arms, like you have seen, like the machineries. They are just doing the stuff like programmed, and also some most of the time involving with electronics and also some programming parts. Let's say you have take a washing machine. There's a program going on, right? You can just tick 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 like that, and it works automatically. So that part is something with the programming part and also involving some electronics part too. So I'm been working as a senior electronic automation engineer there online, and I had a passion of doing like teaching the stuff to the my colleagues during my university career, and thereafter I thought maybe okay, why not I tried teaching the physics. So since I'm specialized with some part of the physics, electronic physics, and yeah, so it worked. So currently it's my 8th year, I guess, learning teaching you the stuff. Uh, and I hope I'm trying my best to deliver the concepts for you guys. Let me know if you are like not getting the things right, since this is kind of a group class, and I think we have already made a group. I think I have, for one of you guys, I have sent you the link as well, right? Okay, okay. So maybe you can send the link to her as well, right? Or else I can just send me a WhatsApp message. I'm I'm in the WhatsApp, but that number that I have given you, maybe you can ask from her, right? And I can add you to the group. So feel free to ask any question, anything at all, related to the physics or maybe related to anything in the life, right? I'm kind of a good consultant as well, right? So yeah, that's all. So we're gonna be like going through this 2.5 years until the A levels, and we're gonna be like doing some more practicals here within the class. There will be, like I have told you earlier, there will be 41 practicals, and out of that we're gonna be in the class we're gonna do around 32 or 31 practicals, 32 actually. So the rest of the practicals we can't do within the class because we need to have the laboratory instruments that specially given for the school labs, and that is why it's recommended to go schools as well if they are teaching. But if the schools are not teaching very well, no point of going. But again, I'm recommending you guys to apply for the Central College Bandarwala. Do you have any schools there teaching English mediums? I think Lyceum works. Yeah, I have been to the Lyceum maybe a few times to do some seminars for the A levels. I know there the English mediums are. How about the school that you are currently going? Which school you went? Okay. How about you? Same. All right. What was the school you went? Ah, yeah. Okay. I think there's no A levels there, right? Yeah. Okay. How about you guys? No teachers are there. Okay, great. Where is the Republican, by the way? Manchester. Okay, working on it. Which means like not in the side of the Gami, right? The other side with that by road. Oh, okay, okay, right, right. Where the Tamil schools and everything are, I guess. Is there a Tamil school there? No. Ah, okay, okay, fine, okay. So yeah, make sure you guys apply for the Bandra Central College. Once you get the results, they're gonna put up that sheet. I'll let you know too, and I can maybe grab it from the school gate and send it to you too, right? Just fill it and send it, and there will be interviews going on, and you can, if you are lucky enough, you will be selected for that college in Bandara. That is going to be the, it's not my, I'm saying that I went that school, but it's going to be the greatest school, I mean, right? For the English mediums, actually. Maybe you can apply for the science college as well, which is at Harliala, going to be somewhat distance, but that also has the A levels in English mediums. So yeah, you can apply from like apply private as well. That's totally fine without applying to any school. But there will be a little procedure filling up with these practicals, and you should grant from a recommended school. I'll let you know about those things, right? It's okay to apply private, but make yourself occupied with more questions. Within the class, I'm going to give you all dozens of these tudes. So in your study table, make sure you are leaving a space to stack up the physics tudes, right? It's going to be around 100 tudes or maybe more, right? For the entire course, right? And again, the next thing is when you are doing the questions from the tude, make sure you are writing it in a separate book or maybe some piece of sheets so that your note will be much clear and the tude questions will be separated and all the example questions and what we're going to learn will be on the book that you're going to write. So for the tude questions, it's not going to be a very fancy book. You can grab any old book that you are having, right? Tear some pages or maybe you can use the same book. Yeah, so if you are applying private, make sure you are always occupied with the questions. Otherwise, if you go schools, they're gonna like always giving some tests. In the class also, we're gonna be doing many papers, but in the schools, they're gonna have some term tests, unit tests, and maybe every day the teachers are teaching. So maybe you can hear the same thing again and again and again, especially for the bio, right? It's good to have like the concurrent follow up. So if you are going for the classes and schools, they're going to teach up the same things. So it pushes into your brain. But if you are like not going for school, then it is totally fine. But you need to be self-occupied with the subjects, right? All right. So with that being said, we can wind up for today, and see you on next Monday. Actually, thank you for joining the class. Have a great week.